It's alive!
Ah, yes, indeed, it is alive. After recapping this thing and replacing all the resistors that were out of tolerance, we now have a working radio once again. I know the last time it only worked for a couple of minutes, but this time we've got a good working radio, and we're going to begin part 4 of this session on how to align it. And this is a little bit different than your standard All-American 5 and All-American 6 radio, since it has a short wave band on it. There are a couple of additional steps, but nothing you can't handle. It's pretty simple. The alignment procedure for this shows that the company that built this radio put some nice alignment marks on the dial here that they tell you to go through. I don't know if you can see that or not, but there's one right. Oh, it's hard to see. Let me get my light out here. There we go. There are 2 alignment marks here up around the high end of the band, and 1 in the middle, and 2 down at the lower end here where my finger is, to aid in alignment. Now, what you'll want to do before you get too far on this, of course, if you can at all possible, download a schematic to this and the alignment procedures. A lot of times you can find these quite easily online under boat anchor radios or something like that. There's a couple of places you can get them, but I would definitely encourage you to do that, because they can be a little tricky at times to align. So we'll just run down the procedures here. First thing I want to point out on this is that you will need a couple of tools, not very many. Just on this radio, all you need is a alignment tool in the form of a screwdriver, which I would also encourage you just to use a regular screwdriver. Now, you can do this because there are no ferrite cores in this radio, since it uses trimmer capacitors on top the IF transformers, as you can see here. So that makes it a little easier for an older radio, because usually those ferrite cores are so locked in there you have to break them to get them loose, and that's never a good thing. And so really all you need is a screwdriver, and I've taped off the end of this metal screwdriver here for the simple reason that sometimes on these transformers and also on the variable capacitors up here where these alignment points are, if they wire these wrong and this trimmer screw is attached to one side of the B plus voltage, if you stick a metal screwdriver in there, it isn't insulated, you'll short that metal, that B plus voltage to ground. And if you do that, you could very easily burn out the IF transformer, and you don't want to do that. So if you use a metal one, go ahead and tape it off, put a piece of heat shrink tubing over it or something, just so you're not going to have a problem with that. The other thing you'll need for the alignment is a signal source of 455 kilohertz, and for this one also the shortwave band you'll need I think 11 megahertz source. And you can either get out your handy dandy signal generator, as long as you can modulate it to around 400 cycles audio. That'll work just fine. And but today I'm going to try something a little different. I bought this a while back and haven't really used it too much, but I'm going to use it today. It's a little tiny SA, and we're going to try that and see how that works out. Now, before we begin, we'll of course go ahead and get our oscilloscope setup. Now you can use a voltmeter, AC voltmeter, or an oscilloscope, either way. Or if you want, you can just use your ear. If you have a nice ear that can tell the difference between levels, you can do that. If you don't have a scope or just a regular AC voltmeter, you can do that. So we'll go ahead and get set up here, and I'll read through the directions on how to do this so we don't lose our place. And the first thing it says to do, of course, is to remove the chassis and the loop antenna from the cabinet. Now, this is also a little different. It's not a backboard loop antenna. It's actually wound around a frame of wood. And so it's kind of hard to get out. You just have to take 4 screws out of there. And they want you to set up the chassis that's as close as possible the way it's going to fit in the radio. And so since we have to get to all these alignment points in here, we'll just go ahead and leave the chassis out and as close as possible to the loop antenna so we don't get any odd interaction that would throw the alignment off. So let's go ahead and we'll get set up to do that. Now the first thing, of course, you want to do is turn on the radio and set your input voltage to about 120 volts, which is pretty much standard around here. I'm using this Variac running through a dim bulb current limiter just in case I slip with the metal alignment tool and short something out. And so I'll set it to 120 volts, which is what it usually runs around here. And it'll vary a little bit with the air conditioners kicking on and off all over town, since it's quite so hot out here now. Okay, and then we'll go ahead and we'll turn on our tiny SA and get it set up. And the first thing you do on this is you set the mode to switch it to low output. That means it's going to send a signal out to this low port. And then we'll set the frequency and we'll start out, I think, at 455 kilohertz. So we'll just put that in here, 455K. And we'll leave the level set where it's at because it's usually pretty high. And modulation, we're going to modulate this using amplitude modulation, and we're going to set it to about 400 cycles, 400 hertz. And then go back, and then we'll turn that on. And now we have a signal going out through the low port here. Now, you notice I have a attenuator in here. It's like a 40 decibel attenuator, I think it is. And the reason I put that in there is because these little tiny SAs, although they're really, really nice, they're very easy to destroy if you happen to put your signal input in the wrong place in the radio that's has too strong of a signal or has a lot of B plus on voltage on it. You'll blow the low noise amplifier out on the front end of this thing. You don't want to do that either, so you'll be buying a new one. At least they're not too expensive. So we'll go ahead and leave that attenuator in here. And the other settings, I think the procedure has you do also tell you that there are 4 calibrating lines stamped on the dial. Yes, we got that. Output of the output meter should be across the speaker voice coil. Okay, we did that. And I've got the my oscilloscope right across the voice coil wires there. And we've got it tuned up here and to where we can get a nice radio signal and nice display. And one other thing that this scope and most scopes have is a ground input here, to where you can tie both the ground of the oscilloscope and the ground of the chassis to the same place, because If you don't, I'll show you what happens if you don't do that. You'll see you get a 60 cycle noise signal there, and it makes it kind of hard for the scope to sink in, and it also throws a lot of things off. So you'll notice that when I hook this up, that levels that out really nice, and so it makes it a lot easier to see the trace on the scope there. And that's something I've never done in the past, because most of the time B- is on the chassis of the radio, and you usually connect your negative lead of your oscilloscope probe to the chassis. Well, not in this case. This is kind of isolated from the chassis through a capacitor. And so what they want you to do is connect a negative lead and run it through a 0.1 microfarad capacitor. I'm sorry, a 0.22 microfarad capacitor. And then connect all your ground reference points from your signal generator and your scope to that point there. And then in step 4 here, I think it says, yeah, connect the ground lead to the B-. And that's what we did. We found the B- point over here in the chassis. And that's this 22 picofarad capacitor right here. Oh, a 200 picofarad mica capacitor. And connected to the control grid of the 12SA7, which on the schematic is right here, and they call it the first detector and the oscillator. Our first tube in here is an RF amplifier, but the second one is the oscillator. Now in an All-American 5, you won't have this RF tube. You will only have these other 4 tubes and a rectifier. So we will connect it to pin 5 of that tube, and an easy way to do that is, I found out, at least on these radios with octal sockets on it, you can just push the wire lead right in between the pin of the tube and the socket connection, and it makes a nice snug fit, and it's not easy to pull out, and it doesn't make too much racket when you connect it. So we're going to go ahead and go back to our directions here, our alignment procedure. And the first thing it says to do is to connect to the control grid, of course, with a 455 kilohertz signal. Any point where it does not affect the signal is where you want to tune the receiver to. So we'll turn the volume up here, and we'll just tune it to a blank spot on the radio. Okay, and then we'll go ahead and connect our lead. Okay, so we have our generator connected. We have a tone coming through the speaker, and we have a signal on our oscilloscope. And I am going to go ahead and start the alignment now. And first off, it says to adjust trimmers 1 and 2 of the second transformer, IF transformer, and 3 and 4 of the first IF transformer. Okay, so we'll start with 1 and 2, and on the pictorial here, 1 and 2 is the inboard part of this transformer right down here on the bottom. Pardon the camera movement, but and we'll see if we can get that in the slot. There we go. Okay, it's in the slot now, and okay, we're going to look here and we're going to adjust for maximum deflection. Okay, I'm going to turn the volume up slightly so we get a better signal. And we'll peak that out. And then we'll go to the other trimmer up here. It was off a little bit, wasn't it? And we'll peak that one out. Okay, that one wasn't too bad. Okay, now we'll go to the first IF, which is 3 and 4, and that would be the outboard side of this one. There we go. Okay, now we'll adjust it for maximum. Oh, that one was out quite a bit. And then we'll go to the other trimmer. And that was off just a little bit. So, and then our next step will be to tune the dial to 1500 kilohertz. And 1500 kilohertz is a reference line stamped into the metal dial plate, first line on the right. So we'll go ahead and tune the dial here. And we'll get as close to the first line mark as we can. And I'll leave it there. And we'll change this, set it to 1.5 megahertz. Okay. And we'll leave the modulation set there. And it's trimmer number 5 right here. And that is the outboard trimmer on the cap here. So let me reposition my... I'm not hearing anything there yet. Let me turn the volume up a little bit.
I am depressed.
Let me go in and find out what's happening here till we get a signal. And I'll be right back. Well, I think I figured out why I couldn't get a tone out of this. I have the radio set to the mark on the dial, but I cannot get the oscillator to tune into that frequency on the dial. I can get it about way up here around the 1.6 megahertz part, but when I try to tune it down low, I just can't get enough room on this oscillator trimmer to get there. And so there's something going on with the oscillator variable capacitor here that's keeping it from tuning down into the range where it's supposed to be. So I think what I'll do on my next step, I'm going to open this up and see if cleaning that will help be able to tune the frequency down a little bit on that. So I'll do that right now. We'll go ahead and turn the power off to all this. And we'll see about taking this apart. See if I can get a little closer view here. And I think all we need to do is pull this screw out. We'll set that aside and see if we can get under here and maybe pull this mica strip out without losing it or damaging it. Maybe it has some silver mica disease in it or something, but looks pretty clean. But I'm going to go ahead and clean that anyway and clean underneath the tab here. That's all there is to that, is just two pieces of metal separated by a strip of mica. So I'm going to get out our little non-lubricating cleaner here and spray a little on there. And then down here, where I made this mess, isn't that pretty? Mica strip there, I'm going to clean that up a little bit. And if that doesn't work, I think I'll try cutting this strip down a little bit. Give it a little less cross-sectional area.
That might help.
There's probably a number of things a guy can do to fix that, but we'll start with the least invasive and least destructive part of it. Okay, let's see if we can get that screw back in there without losing it. And we'll start about right there. We'll go ahead and turn on the power. We need to turn on the signal generator here. And I'm going to set it to low out. And we'll set the frequency to 1.5 megahertz. Modulation will be AM. Frequency will be about 400. And we'll kick her on. And we'll just do a little antenna coupling here to see if that will pick that up anywhere. I'm not hearing anything yet. I'm trying to get this needle to be over on the mark here, right where my thumb is. But I'm still about a 1/4 inch away from making it to that first mark there. So, I don't know if we did it any good or not. You'll notice here when I push down on that tab, it tunes a little bit. Well, we might have to see if there's something else going on in this radio that's throwing the oscillator off so far. I'll be back when I figure out what it is. Well, after working on this for several days, trying to figure out what was going on, I've come to the conclusion that I can't figure it out exactly. I've done a couple of things that will help. For one thing, I've taken the screw completely out of the trimmer capacitor right there and removed the screw, removed the mica insulator, and just left it out here kind of flapping in the breeze. And that got the dial pointer a little bit closer to where it should be when you tune for the proper frequency of that. So I did that. And another thing I did was readjusted a couple of the I'll try to point to it here. There's a couple of wires down here that go to the oscillator coil in the center of the screen here. See if I can get that to focus a little better. And just repositioning those just a little bit, going to the tube. And let me see if I can point this out a little better. Yeah, okay, this is the oscillator coil right here. And the wire coming from the capacitor on the other side of the chassis comes right down through here and underneath, and then it ties into a switch and then a coupling capacitor to the oscillator tube, which is right here. And repositioning this just a little bit helped move that frequency enough to where the dial pointer worked out just fine.
If I push it any harder, the whole thing will blow.
It's not the way I'd like it, but other than tearing the whole front end of this radio down and risking damaging or moving something else, I decided to abandon that idea of replacing some mica capacitors, which are probably okay in there. So we'll just continue on with the alignment procedure, and I think we'll start here on the shortwave band, and we will get our signal generator, and we'll set the mode to switch to low output, set the frequency to 11 megahertz, and the modulation to AM, and the frequency about 400 cycles. Okay. And we'll turn it on. Okay. Now we'll get everything positioned here, and I'll show you the procedure on aligning the shortwave band. All right, according to the directions here, we will connect the 400 ohm resistor to the external antenna clip on the frame of the radio here. And we've done that. And we'll set the pointer to, or set the frequency to 12 megahertz. We did that, and we will set the pointer to 12 megahertz, reference the line stamped into the metal of the dial plate, second line from the right. Okay, and the dial pointer is here, and we will go second line to the right is about right in there. Put the camera back on the tripod, and we will continue on here. Let's see if we can get a signal out of this. Sounds like we're fairly close. You can hear it a little bit in the speaker, as you can. And then we will adjust trimmer number 8. is right here, about midway through into the chassis, which would be this trimmer right here. Let's go ahead and adjust him. Well, that's plenty loud there. I think we'll cut down the signal strength a little bit here. About 10 decibels, maybe 20. Oop, that's too much. We'll just cut it down 10 decibels. Okay, looks like we got a peak on that one. And it says, adjust to bring in the signal. Check to see if the proper peak was obtained by tuning to approximately 11.1 megahertz. Okay, we're set at 12, but let's tune the radio down to 11 megahertz and see if we can pick up a secondary image here according to the directions. And there it is. See on the oscilloscope that it's there. And so we are, we don't have to go any further on that step. Now let's go and tune the shortwave antenna. And we just go back to our 12 megahertz position on the dial. And we will adjust this trimmer here for maximum output. Okay, that is maximum output. So according to the directions, we are done with the alignment on this radio. So we'll go ahead and put it back in the cabinet and see how things line up on the dial. And I think we could do that right now. Let me just put this down here in the right position. Okay, that should be 12 megahertz on the band here. So we have it on the second mark, which should be around 12 megahertz. And I've got my dial scale here lined up. This line here corresponds with that line behind it. And what I can see, that is exactly 12 megahertz. Well, at least that one lines up anyway. Unlike the AM band, it's not too far off, maybe a quarter of an inch on the dial. But when you get down to the low end of the dial here on the AM band, it's much better. It's much more accurate. So let's go to AM. And
home of Hayes' greatest hits. 94.3 FM, 1400 AM, KAYS. Hayes.
That's our main station. And I'm going to tune it down here. Save some time. To this channel.
Called Bethel on July 5th. We did not celebrate 4th of July.
And this one's at 550 on the dial. I'll put that down here at, and it's pretty good. I think it's 550, 540 or 550. I can't remember which, but anyway, this station is 100 miles down the road here, so it's picking it up quite nicely.
So it was was quite a robust family that worked upon.
And it, quite sensitive radio.
Very, very young boys, so they realized.
So my friend should be happy with the way it performs, I think. Well, that about does it for this episode. I want to thank you for watching and sticking with me through this. I think as soon as I get this back in the cabinet, I'll show you what the cabinet looks like. So stand by. And just like that, it's finished. Well, maybe not just like that. Did take a while, but want to show it off here. It is all done, and I've been burning it in and soaking it, as they say, for a couple hours here. Everything works pretty good. It's lots of stations, AM stations.
He doesn't like the company I keep.
Quite a few of them.
Think of that?
For an AM band, it works pretty good. A lot of these stations are clear into the next state and hundreds of miles away. So it's working pretty well. It's the middle of the afternoon. I'll try a shortwave station here, see if we can pick anything up. I don't know if we will or not. Since I'm down. Oh, there's one.
No one comes to the Father.
All I've got is this little length of wire for an antenna on that. So, in the 31 meter band. It is late in the afternoon, so we probably won't pick anything up on the 25 meter. Just not a lot going on at this time of the day on those bands. So.
Good times, tattoos and memories, and asking on trial for what is what.
Yep, it's working quite well. And after replacing numerous parts, capacitors and one rectifier tube, we also, let me show you the backside here. Phenolic board's in pretty good shape. Put a new line cord on it. Little external antenna there, which doesn't really need it, really. It picks up pretty well. But he didn't want to do anything to the cabinet. He's an old car guy, and he kind of likes to keep things original. So I didn't really replace any of the missing pieces of veneer or anything. I just went over it with some Danish oil. Spruced it up fairly well. So anyway, that is the completed project, and I really like the way it came out. So I want to thank everybody for watching, and hopefully it won't be too long for my next video, but in case it is, have a great summer or fall, winter, however long it takes. Sure appreciate you listening in. So we'll catch you all next time. Thank you.